Hi, everybody. Mr. Gerhard here. Just wanted to kind of go over a couple quick um, things about how to find probabilities using the standard normal model. So the first thing we're going to do is we're going to say, okay, what is the probability that, or what percent of all cars get less than 15 miles per gallon? Now, we already know that this is a normal distribution with a means 24 and a standard deviation 6. So we always write this telling us the parameters, what type of model it is. We know that 15 is like right here. So what we're going to do is we're going to just say x equals 15. That's our boundary. And then we go ahead and we shade to the left because we want to say, what's the probability it's less than 15? So we're going to say probability that x is less than 15. And what we want to do is we already know like the 68, 95, 997 rule. What we want to find out is less than 15. Well, we don't know what that is because it's in between these. So what we're going to do is we're going to change it to a z-score. And to find a z-score, we're going to do z equals, that's the value 15 minus the mean 24 divided by the standard deviation 6. So in this case, we got negative 9 over 6, which is negative 1.5. So as we go through this now, we're going to say, what's the probability that z is less than negative 1.5? Now, again, the probability that that occurs is, well, somewhere between 16% and 2.5%. That's not accurate enough. So what we have to do is we have to go to the table. Now, on the table, you'll see that on the left side are z-scores down to the 10th, and across the top are hundredths. So we're looking for a z of negative 1.5. The negatives are on the front, the positives are on the back. So negative 1.5 is right here. Negative 1.50 is that one right there. So 0.0668. 0.0668 is the probability or the area under this curve. And that means there's a 6.68% of all cars get less than 15 miles per gallon. All right, so we have a couple things here. I want to make sure that you take note of this because it's very important. We have these on every setup. We have to have our parameters, okay, and that leads to a drawing. So once we have our parameters on our drawing, then we need a boundary point. We can do that in the drawing here, but we can also do it with our probability statement here. So 1 is our boundary and parameters, 2 is the boundary, 1 was just our parameters and model, 2 is our boundary, 3 is how do we calculate the z-score and what probabilities that give us, and then 4 is the answer in context. So when we set up these problems, those are the 4 things that we're going to do. I'm going to go on to do one more, and then we'll split up this video. So now the question is, what percent of cars get more than 40 miles per gallon? So 40 is out here. So we'll make a little setup there. We'll say x equals 40 there. We got n 24 comma 6. And we're going to say probability that x is greater than 40. Now we got to convert that to a z-score. So z is greater than, let's see, z equals 40 minus 24 divided by 6. What is that, 16 divided by 6. Come over here. Let's do that, 16 divided by 6, 2.67, okay? So come back here, 2.67, which is about right. There's 1, there's 2, there's 3, so 2.67. So now here's the problem though. If I go to the normal probability chart, here's 2.6, we come all the way over to 2.67. That doesn't look like 99.62% of the area under the curve. It looks like a lot less than that. If we go back and we were to look at the actual charts, this is always area to the left. So when we have these values, every time we look at a value on the table, it's area to the left. Well, if I want to find the area to the right, it's going to be 1 minus the probability that z is less than 2.67. Okay, so if we do that, 1 minus, let's do that on the other page. So this is going to be 1 minus the probability that z is less than 2.67. That's going to be 1 minus 0.9962. Which is going to be 0.0038. So there's a 0.38% of cars get more than 40 miles per gallon. Okay, again, 1, boundary 2, work 3, answer in context 4. All right, and then I'll do 2 other videos to show you about the other 2 examples.